Good afternoon to all. My name is NURUL Binti Abdullah. My matrix number is F25A1970. Today I am presenting my project, the Body Yield and Bioscience Simulator. It's a tool that designed to tackle that critical challenge of national food security using engineering mathematics. First of all, in Malaysia, maintaining our rice self-sufficiency level is a top priority for RENNY rice. However, unpredictable weather and terminal drought stress during the post-flowering flowering phase threaten this stability if farmers drain their fields too early, or if they harvest too late, the grains become chalky, shatters in the fields, or break during milling. So basically, the farmers rely on rough visual guesswork to decide when to harvest. My project is about the guesswork with precision by using a different calculus beside on my right part using the current calculus formulas. Let's look about the mathematics driving the engine. Crop dry matter accumulation naturally follows a sigmoidal pattern. We model the cumulative grain weight of a pinnacle of 35 days of post-flowering windows from day 1 to day 25. However, cumulative weight doesn't tell a farmer the current speed of growth. For that, we take the first derivative here. Applying the equations and chain rules tells us the exact speed of nutrient mobilization into the grain envelope. Biologically, the starch deposition velocity, it measures the precise rate at which sucrose is being cleaved and packed into amylose and amylopectin granules inside the endosperm. Pinpointing when is maximal allows precise management of environmental buffers. I built this responsive web simulator using the Tailwind CSS for mathematical rendering, fully anchoring our input to validate the data sets. Notice how the chart instantly recalculates. If you can see from first to the last 34 to the 34. Okay. To make this highly practical for field operation, the simulator translates these derivatives into three critical agronomic phases. First, the milky stage. The first is the milky stress. This, if you can see here, around day 5 to 10, the derivative is accelerating sharply. So, okay, the second is Dove test. Open DOSM Agriculture Hub, Mardi Scientific Repository, Mudra Agricultural Development. Okay. And lastly, it's about the Open DOSM. This is our target as we hit 24 to 35 days. The first derivative flattens the age 20, okay, here 28 to 35. The first derivative flattens and approaches zero. Growth has completed. The simulator gives a clear operational alert. Okay. Ultimately, this is simulator proves that calculus is not just a theoretical, but it's a tool for national resilience. By bridging the pure mathematical by bridging pure mathematical calculus with agronomic reality, we can empower agriculture officers to make data-driven decisions and protect Malaysia's food bowl. For future code enhancement, I plan to refactor this monolithic script into a clean model view controller design patterns, separating the biological logic from the presentation layers, make the code base highly modular, maintainable, and industry scalable. And then I want to implement the mathematical optimization loop with the script. The algorithm will scan the derivative values programmatically to pinpoint the exact optimal drainage. And lastly, I will say that this allow the agricultural officer to download the application into their smartphone and run complex different calculation.
My name is Binti Maisarah. My major number is F351643. And I'm majoring in food security, and the bioscience topic that I chose is smart medical analytics. And for the summary of the poster is the problem assess the problem addresses Malaysian rice food security specifically focusing on optimizing paddy growth in Kedah to meet the country target over 75% self-sufficient level. Paddy plants do not grow at a steady linear pace. Instead, they follow an S-shaped logistic curve because growth rates constantly change. Farmers struggle to know the exact biological moments when the plants need resources the most, leading to potential fertilizer waste or stern crop yields. The importance of studying this bioscience problem is to achieve national food security. Optimizing yield help Malaysia reduce its heavy reliance on expensive price import. Second, prevent resource waste, which knowing exact growth pieces prevent the over application or under application of expensive nitrogen fertilizer. Third, optimize water management, which pinpoint when to flood or drain field, which is benda, preserving local water security. Lastly, modernize Malaysian agriculture, which introduce calculus-driven precision farming technique to undergraduate bioscience students and future agro-technologies. And for this graph, for MR297 MARDI ALEYA, and on variety under deficient and drought stress condition, the nitrogen input is deficient, which the mechanism is very lower, the growth rate constant. The danger nitrogen is conditionally building block for chlorophyll and amino acid. Deficiency stunts cell division, causing chlorosis, yellow on leaf, or yellow of leaf, and delaying the vegetative development timeline. Second, the water availability, which to drought stress, the mechanism drastically reduce the maximum potential height. The danger water stress eliminates turbo pressure within plant cell, which physically halts cell elongation. The paddy plant remains permanently stunned, and catastrophic reduction in follicle formation. And secondly, under optimal condition, at the 55 day crop cycle, this inflection point of growth curve at this is not a transition from vegetative growth to reproductive growth. The corporate height is the specific physical height the MR297 plan reached at day 55, serving as visual benchmark for healthy structural development. And for the growth rate, the absolute peak speed, the plant growth cells are elongating faster than any other time in the life cycle, meaning the plant has an extraordinary appetite for nutrients. For the biological action, because the derivative is at its maximum, farmer must keep field permanently saturated, 5 to 10 cm of water, and apply target nitrogen to support the heavy cell division forming the rice grain heads. And the last phase, under excessive and water cloud condition, the nitrogen input is excessive boost. Mechanism spike the growth rate constant, accelerating early cell division. The danger of over-fertilizing with area causes rapid weak structural growth. The plants become top heavy, excessively tall, and highly prone to lodging, which is falling over before the harvest. It's also increased the vulnerability to pest and fungal blast disease. And the water availability is water clog excess. The mechanism is artificially distort the maximum potential height. And the danger is excessive and permanently deep folding suffocate the root system by cutting off the oxygen supply. This stunt root growth and prevent the plant from extracting soil nutrient efficiently and diminishing total yield. And for MR219, that is lower division and drought stress. Its mechanism, MR219, is historically a high-yielding premium variety bred by MOHD. However, high-yielding varieties generally require strict adherence to resource timeline to reach potential. The danger when hit with nitrogen deficiency and drought is long vegetative reproductive period to at 120 days total versus 115 days for MR297, prolonged exposure to stress leading to massive drop of it from its high genetic yield potential. The shift timeline parameter caused the mechanism of MR219 has longer life cycle, which is 120 days. Its mathematically inflection point shift later is typically around 60 to 65 instead of day 55. The danger under drought, the plant fails to accumulate enough biomass during the stretched out vegetative phase, leading to severely compromised plant formation when it finally reaches its delicate growth. Secondly, under its optimal resource condition, R219 maximum genetic potential realized the mechanism which optimal water availability, so to grow pressure is perfectly maintained, allowing maximum cell elongation to reach its true genetic height potential. The outcome of optimal nitrogen allows the smooth sustained cell division across its long vegetative timeline, maximize the development of stronger tillers and large grain pinnacle. For the shift peak energy timeline, the mechanism because of the MR219 require 120 days to mature its mathematical inflect point delay slightly around day 60. The outcome, the maximum growth rate derivative occur later than the 115-day MR297 variety. Argo technologies must shift their resource calendar to ensure high water saturation and primary fertilizer stop dressing peak precisely at day 60 to fit this late-breaking reproductive transition. Lastly, for this data, at its excessive boost and water cloud excess. First, susceptibility to lodging mechanism premium varieties like MR219 are bred to bear heavy panicle of rice when over-fertilized with nitrogen. The cell division rate constant spike prematurely. The danger, the plant shoot up too fast, developing long, thin, and brittle stem. Because the MR219 stay in the field longer than 120 days, these top-up heavy plants are highly vulnerable to falling over due to heavy rain and wind common in Malaysia granaries like Mada region. For the root suffocation prolonged, the mechanism standing water that is too deep completely block oxygen from reaching the soil layer. The danger for long cycle variety keep the soil The soil high phosphate deprived of oxygen for an extent period prevent healthy roots. The roots begin to rot drastically, reducing the nutrient absorption capacity right when the delayed inflection point demand high energy for clinical production. And to improve the HTML code for this Bioscience problem and to make it highly interactive and visually function, you can replace the static text block with interactive HTML, which is JavaScript dashboard using chart.js.
My name is Dhania Maisarah, Binti Abdul. My number matrix is F25A1974. Today, I will present about ego processing and calculus simulator, median optimization, and farm yield dynamic via first derivatives. First, we look at upstream plantation parameters. This function of this model is to standardize and quantify environmental and biological variables. It ingests critical metrics such as tree age profiles, soil composition, historical weather data, and fertilizer application schedules. By defining these parameters accurately, the system creates a digital baseline of the plantation physical reality, ensuring that any future projections are grounded in true economic constraints. Secondly, we look at interactive yield dynamics dashboard. This function of this dashboard is real-time visualization and simulation. Instead of looking at statistic spreadsheets, stakeholders can use interactive tools to simulate different scenarios. For instance, you can adjust expected rainfall or fertilizer volumes and immediately see how future fresh food bunch (FFB) yields fluctuate over time, making complex agriculture forecasting intuitive and actionable. Next, we look at differential calculus formula. Behind this formula is calculate rates of change and marginal returns. Instead of just calculating total yield, calculus allows us to determine the exact rate at which yield change relative to time, age, or nutrient inputs. By analyzing the derivative of the yield curve, the system can pinpoint the precise moment a tree reaches peak productivity or identify the point or diminishing returns for fertilizer application. Fourth, we look at the downstream agro-processing problem. Harvest crops are highly perishable. Fresh fruit bunches must be processed quickly to avoid a spike in free fatty acids which degrades oil quality. The function of this module is bottleneck optimization. It balances the unpredictable daily harvest volume coming from the upstream plantation with the rigid operational constraints and capacities of the milling facilities, preventing logistical deadlocks and minimizing product spoilage. 5. We look at Malaysia industry validation. The function of this step is to ensure compliance, realism, and market relevance. The algorithm and parameters are calibrated using real-world operational benchmark from the Malaysian palm oil sector, adhering to local standard practice and environmental regulation. This ensures that the model outputs aren't just theoretically sound but completely viable for local estates and means operating in the unique Malaysian climate. Finally, we utilize ergonomic stage shortcuts. Calculating a plantation multi-decade life cycle day by day is computationally heavy and inefficient. The function of these shortcuts is computational optimization. By grouping tree life cycle into distinct macro stages such as immature, young mature, fine mature, and senescent, the algorithm can skip granular daily calculation and use optimized mathematical shortcuts to instantly project long-term 20-year yield horizons. In the conclusion, by combining upstream data, differential calculus, and downstream processing constraints into a single validate framework. This research project provides a powerful blueprint for the future of sustainable data-driven agriculture.
My name is RENNY ROHAN. My number metric is F25A1857. Today I will be present my project about applied biostatistics and Celsius in Malaysia oil palm agriculture. This web page discusses how biostatic and calculus are used to study oil palm production in Malaysia. This main problem is unstable palm oil yield caused by weather, disease, soil condition, and plantation age. This issue is important because Malaysia is one of major palm oil produced in the world. Important of studying this problem because studying this problem help improve agriculture production and economic growth. It also helps farmers predict yield change and reduce crop loss. By using mathematics and data analytics, research can make better decisions for plantation management. In section 1, agronomic variable simulation panel, this one is the section 1. This section shows variables affecting oil palm yields such as maximum yield, potential growth rate coefficient, and infect risk. Changing these values can affect the plantation output. This helps researchers understand how different conditions influence crop productivity. This one is section 2, interact yield and change rate curve. This graph shows the relationship between palm tree age and yield rate. From this graph, production increased during the early years, reaches a peak and then slowly decreases. This curve helps predict future production trend. This one is section 3, yield life stage of Malaysian oil palm. This section explains the life stage of oil palm. At number 1 is immature stage. This palm tree has not produced fruit yet. At number 2, premature stage, production stage to increase. Number 3, senescent decline. All the tree become less productive. Section 4 is mathematic farm work. This section explains how Celsius and mathematic models are used to estimate agricultural productivity. These equations helps scientists analyze growth pattern and project production efficiently. At section 5 is bioscience and agronomic problem. This section discusses real agricultural challenges in Malaysia such as disease, infection, climate change, and declining soil quality. The factor can reduce palm oil production. At section 6, Malaysia agrodata validation. This section provides supporting data and research reference related to Malaysia palm oil agriculture. It helps verify that the information used in web page is relevant. I recommend adding more animation and interactive feature to make web page more easier to understand. In conclusion, this web page shows how biostatic and Celsius can help solve agriculture problems and improve palm oil production in Malaysia. Thank you.